Hey everyone, I'm making this video to document my journey with AniBrain, um, record it for myself and my own learnings as well as other people. Hopefully you're able to take something away from this. Today I'll be talking about ml.anibrain.cloud. It's a server I spun up to do machine learning inferences for a new feature that I'm working on called Chronicles. I won't really get into Chronicles too much because that's not the purpose of this video, but Chronicles will be the first feature on anibrain.ai that allows a user to input content onto the site. And so with that comes a lot of moderation concerns, safety concerns, and just a whole slew of new problems to think through. And so I decided to create a server to do ML inference on certain things that I'm allowing the user to upload, just to check for safety as well as a bunch of other stuff. So I kind of want to walk through that and explain my logic. So first things first, um, the server running this is FastAPI. I decided to go FastAPI instead of other Python-based options like Django or Flask because, well, first I'm using Python because it's machine learning focused and there's just like a lot of support for Python. I decided to go Fast API versus like Flask, for example, just due to performance. From what I can tell, reading a few articles online, Fast API has a proven track record with performance, probably why they named it what they named it. Fast API automatically gives you this like docs um, endpoint to easily test your API as well as view what's available. And so as you can see, we have get and head endpoint for ping, and this is just for health checks, just to make sure the server's up. I use a service to just check for like site health. And then all the post requests are the actual like machine learning inference routes. So we have some routes to embed text, as well as genres. We have some routes to classify text and images to do like analysis on user input. And this analyzed text honestly is just a aggregate of classify and embed text, just one route to get them all rather than having to call routes individually. So I'm going to walk over a bit of the code that I think is important. First, we have a startup file, which does a few things. It initializes the Fast API application, uh, does some work with cores to avoid those errors, and sets up the models that we'll be using for inference in the startup phase. And a lot of these models are Hugging Face models. I fine-tuned one for text embeddings, but for the most part, just directly using models from Hugging Face that have high downloads. My assumption is a lot of downloads means it's pretty decent. Um, and so just leveraging what the community has created. Um, let's see here. Yeah, and then we simply use the models in order to make those inferences. And so the code is actually really short, which is nice. For example, in order to do sentiment analysis, I use a text sentiment classifier is what I called it, and I simply just run the function. And all of these things ultimately are pipelines from the Hugging Face Transformers package. So it's really simple. In order to like read the documentation, understand how it works, and then on the actual routes, again we have these like head and get routes just for health checks. But for the most part, the routes are again really simple. We do some validation to make sure the correct API key was sent. Otherwise, the request will be blocked and the user will get like an unauthorized. The only user should be me, and so this just kind of adds that safety net. to make sure that no one's hitting this application that is not for the purposes of anibrain.ai. Um, FastAPI, I guess, does a lot with like Pydantic, which allows for uh, input validation for requests. So, for example, when we embed text, we claim that this data is a text input. And if we look at text input, I have a validator on it that just makes sure that one, the the text field on the post data is a string, and two, making sure that it's a non-empty string. Um, and so yeah, we simply take a look at the request, extract the relevant field that we're expecting, and run it through the pipeline and return that result. And I ended up with this, the ability to now make machine learning inferences. So yeah, this is it.